All right, diving right in today. We're looking at how to give those classic physics simulations a bit of a modern makeover.
Oh, nice.
We've got some awesome documentation from Open Educational Resources Open Source Physics at Singapore on converting simulations from Easy Java Simulation, or EJS, over to Easy JavaScript Simulation, EJSS.
Yeah.
Basically, we're taking these simulations that have been
Yeah.
around for a while and, making them work on newer platforms.
Exactly. And that's really important for open educational resources, right? Because it makes these really valuable tools accessible to way more students.
For sure, for sure. Now, I was taking a look at the guide, and right off the bat, they recommend using, get this, an older version of EJS. Kind of ironic, using older tech to build for the future, right?
Well, sometimes those older tools were just really well designed and they've stood the test of time. And that kind of shows us how important good design principles are in software, especially in education where you want the resource to be relevant for years.
That makes sense. So the guide then says to open both the old EJS file and a new EJSS file.
Okay.
I gotta be honest, at a first glance, I was a bit lost.
Yeah.
Why two copies? What's going on here?
Think of it like restoring a classic painting. You've got the original masterpiece for reference, but you're creating a fresh canvas to reinterpret it.
Interesting.
So the old EJS file holds the core concepts, and then the new EJSS file, that's where you update those concepts with the more modern language and platform.
Okay, so it's like translating a book. You need the original for reference, but you're crafting something new in a new language.
Exactly.
I'm guessing the code translation isn't always smooth sailing, though, right? There's got to be some hiccups going from Java to JavaScript.
Absolutely. And the guide points out some key debugging steps. For one, you'll see right away is the switch from curly braces in Java to square brackets in JavaScript when you're declaring variables. It's one of those tiny little syntax things that can trip you up if you're not used to it.
Instead of just swapping symbols, can you explain a bit more WHY that change is necessary?
So it comes down to the way Java and JavaScript handle data types. Java is what we call strongly typed, meaning you have to specifically say what kind of data a variable will hold, like number, text, and JavaScript is more flexible, loosely typed.
Okay.
So you just use var to declare a variable, and JavaScript will just kind of figure it out on its own.
So those curly braces in Java are basically shouting, hey, pay attention to the type of data here.
Yeah, pretty much.
JavaScript is like, whatever, I got this.
Exactly. Another change you'll run into is replacing int with parseInt when you're converting values to integers.
Got it.
So really, it's not just randomly swapping things out. There's a logic to it based on those differences between the languages.
Makes sense. Makes sense. All right, so we got our variables taken care of, but physics simulations are visual, right? So how do we handle drawing elements in EJSS? I can't imagine it's just a copy and paste.
Yeah, no, it's a little more tricky. Say you're drawing a polygon. In EJS, you might have separate arrays for the x coordinates and the y coordinates.
Yeah.
But in EJSS, you've got to combine those into a new multidimensional array format, like you're taking two separate lists and merging them into a table.
So we're restructuring the data to fit the new framework.
Right. And the guide actually has a really clear example of how to do this for polygons, which is helpful.
Nice. I also saw they mentioned using dotted lines for certain elements to make the visuals clearer.
Yes.
I like that attention to detail. It matters.
Yeah. In a complex simulation, that visual clarity is key,
Right.
You've got multiple objects moving around, interacting, so those little cues like dotted lines can help people, distinguish different components and understand what's going on.
It's a good graphic design, making the info easier to digest.
Yeah.
Speaking of easier, the guide talks about cleaning up unnecessary code from the EJS file. Things like language detection or play pause labels that might not be relevant anymore.
Right. It's always good practice to streamline that code and make it more efficient and readable. Yeah.
Like decluttering your desk.
Exactly. Oh, and color handling. That needs adjusting too.
Okay.
Instead of Java's color class, we'll use a custom RGB function in EJSS, which again, just highlights those differences in how the two languages approach things.
It's all about simplifying and focusing the code.
Yeah.
Making it more manageable.
Right.
So at this point, if we've done everything right, the core simulation should be, what, runnable?
Yeah, you got it. You should be able to run your simulation in EJSS. But we're not done yet. The next step is building the user interface with HTML.
Right, because the simulation itself is one thing, but how people actually interact with it, that's a whole other piece.
Yeah.
So where do we begin with that?
The drawing panel is where it all starts.
Yeah.
This is where you lay out all the visual elements that users will interact with, like Buttons, sliders, text boxes, even graph.
Like designing a dashboard for the simulation.
Exactly. And the guide mentions looking at other EJSS files for inspiration when we're designing the layout.
I like.
Yeah. Don't be afraid to borrow ideas, see how others have tackled similar design challenges. Good way to get those creative juices flowing.
Makes total sense.
Yeah.
And I appreciate how the guide stresses testing along the way. It's not about getting everything perfect at once.
Right.
It's about making small changes.
Yeah.
And seeing how they affect things.
It's an iterative process.
Exactly.
It's a key concept in software development. You
Yeah.
build a little, test it,
right.
refine it, and repeat.
They even have the example of adding a lens group and seeing how it changes things.
It's very hands-on.
It is. It's like being a scientist conducting an experiment.
Exactly.
Carefully observing the results.
Yeah. And that's a perfect lead-in to the next part of our deep dive.
Okay, so we've kind of laid the groundwork, tackled the code,
Right.
and now we're starting to think about how it all looks for the user.
It's like we've built the engine and now we're designing the car around it.
Exactly. And speaking of design, you mentioned the drawing panel before. Can you break down what that looks like and how it works within the simulation?
Sure. So imagine like a blank canvas.
Okay.
Where you can drag and drop different elements, buttons, sliders, text boxes, even graphs.
Right.
That's your space to create the interface, the controls, for someone to interact with the physics.
So it's not just about coding the physics. It's about designing the tools to let people actually explore those concepts.
Yeah. You're giving the user the power to tweak variables,
Right.
run experiments, and see those results in real time.
That's what makes these simulations so cool for learning. It's not just reading about it, it's actually doing it.
Exactly. And that's where good UI design comes in. It's about making those tools intuitive and engaging. And the guide actually recommends checking out other EJSS files for inspiration.
Nice. Yeah, like looking at different car dashboards
Exact.
to get ideas for your own design.
You might be surprised at how creative people have gotten with the drawing panel to create some really unique learning experiences.
This reminds me, when I was looking through the documentation, the website has a ton of other physics simulations and resources.
It does.
All freely available. It's pretty amazing.
It is. That's the beauty of the open educational resources movement. People sharing their work, collaborating, building on each other's ideas. It's great.
Yeah, it creates a real sense of community.
It does.
A shared passion for making physics accessible.
And the best part is you're not limited to just using what's already there.
Right. Yeah.
You can customize them, make them fit your teaching style or the needs of your students.
So it's not just about recreating the past.
Right.
It's about shaping the future of physics education.
Exactly. And by empowering teachers to adapt and create, it opens up so many possibilities for how physics is taught and learned.
Absolutely. Okay, so back to the process. How do we actually bring in the HTML for the interface? Is it just copy and paste from the EJS file?
Not quite. We are moving from Java to JavaScript, so
Right.
there's some translation involved. But the structure of the HTML itself, that might not change too much.
So like translating a blueprint, but with a different language for the building.
Perfect analogy. And the guide has examples of how to adjust certain elements. For example, it talks about creating a reset button,
Okay, yeah.
which is essential for letting users start the simulation over.
Like a rewind button for your experiment makes sense.
Yeah.
But I imagine there are times when you need to create something entirely new for the EJSS version.
Oh, absolutely. That's where your creativity as a designer comes in. You might need new sliders or input fields or even visualizations that weren't in that original EJS file.
So it's not just technical skills, it's design thinking too.
You got to think about how users will interact with it, what info they need to see, and how to present it all in a clear and engaging way.
This really shows how software development is a blend of technical know-how and creativity.
It really is. That's what makes it so interesting. You're not just writing code, you're building an experience.
And a learning experience in this case.
Right. And the more we think about the design,
Yeah.
the more impactful that learning is going to be.
It's like writing a story. You know, each element adds to the whole narrative. Speaking of stories, the guide really stresses this idea of iteration. Why is that so important, especially for someone who's new to this?
Well, when you're doing something complex, like recreating a simulation, it's easy to feel overwhelmed if you try to tackle everything all at once.
Yeah, like trying to write a novel in one go.
Exactly. That's where that iterative approach helps. Break it down into smaller chunks, focus on one element at a time, test it, refine it, then move on to the next.
Makes the whole project less scary.
It does, and it lets you learn and adapt as you go. You might realize something that seemed good in theory doesn't actually work so well in practice.
Or you find a brilliant solution you hadn't thought of before.
That's the beauty of it. It's a process of discovery.
And that discovery makes it all worthwhile. You're not just following instructions.
Right.
You're exploring, experimenting, and learning as you go.
Perfect mindset for anyone who's into physics education.
It is. Because in the end, it's not about the code, it's about the learning. Speaking of which, this guide goes into some serious detail.
It does.
Converting variables, adjusting visuals, even creating custom functions. Is all that detail really necessary for someone just starting out?
I think it's super helpful. Remember, the guide isn't just instructions, it's an educational resource itself.
Right.
By giving clear explanations and examples, it helps people understand the concepts behind it all, not just the mechanics.
So it's like a mini crash course in simulation design built into the guide.
Exactly. And that's what makes it so valuable for anyone who wants to not only recreate these things, but to understand how they work and how to create their own.
It's like learning to bake a cake from a recipe, but also getting a mini lesson in the science of baking.
Great analogy. That deeper understanding will help people take these simulations even further, adapt them, customize them, create new learning experiences.
So it's not about just copying the past.
Right.
It's about building on it and innovating, pushing the boundaries of what's possible.
That's what's so exciting about all this.
Right.
We're not just preserving a legacy. Yeah.
We're shaping the future of physics education.
I love that. Okay, we've talked code, we've talked design, we've talked process. What does all this actually mean for the user? What's the impact of bringing these simulations into the modern age?
It's opening up a whole world of interactive learning, giving students the tools to explore physics in a way that's engaging, intuitive, and fun.
It's making physics come alive.
And by making them accessible on modern platforms, we're reaching more people, sparking curiosity, and maybe even inspiring the next generation of scientists.
That's a pretty awesome thought. So as we wrap up this part of our deep dive, what's the one thing you want our listener to walk away with?
I want them to remember that this isn't just about technical skills or following steps. It's about passion, creativity, and wanting to make physics education the best it can be.
Beautifully said. And I think that's a perfect place to pause for now. It's just really cool to see how much effort has gone into these resources, making them available for everyone.
It is. It shows what open source and collaboration can do for education. Totally. So we've covered a lot. The why behind all this, the technical how-tos, even some design stuff.
Yeah, and we talked about how this whole process can actually be a great learning experience in itself.
It really can. But now I want to bring it back to you, the listener.
Yeah.
You're here, you're checking this out, you're clearly someone who cares about physics education.
Absolutely.
And that's what's so awesome about this whole thing. We've gone through the steps, but the real magic happens when you take this and run with it.
Now that you know you can recreate these simulations, what kind of unique learning experiences are you going to create?
That's the challenge, right?
Yeah.
Don't just think about recreating the old stuff. Think about what you can build for the future.
Think about your students, your teaching style, the concepts you want to get across. How can you use these tools to create something special?
Maybe you'll design a simulation that lets people play with gravity.
Yeah, or explore fluid dynamics in a virtual world.
The possibilities are huge. You're not just following a recipe anymore. You're the chef now, creating amazing physics learning experiences.
And the best part, you don't have to do it alone. There's a whole community out there, sharing and supporting each other.
So don't hesitate to reach out if you get stuck. And remember that full document with all the instructions and links, that's on the Open Educational Resources Open Source Physics at Singapore website.
A ton of info to explore.
So go out there, experiment, create, share your awesome simulations with the world.
Exactly.
Who knows, maybe someday we'll be featuring your work on the deep dive.
I would love that.
Until then, keep diving deep and keep that passion for learning alive.
See you next time.